So this lesson is all about what's called absolute value. Before we can start talking about absolute value, I want to take a second to look at the number line and specifically how it relates to negative numbers. We're going to do that first by talking about some positive numbers first. Now everybody's familiar with the number line and its use for talking about positive numbers. And if we count from the left to the right on the positive side of the number line, we go from 0 to 1, 2, 3, 4, 5, etc. That we're familiar with. Now on the negative side, the numbers still increase from left to right, but where we're used to seeing 1, 2, 3, 4, 5 increase from left to right, we start counting down from 0. So the first number we get to on the negative side is going to be negative 1, negative 2, negative 3, negative 4, negative 5, etc. So when we actually look at the negative side of the number line, we see that we start with negative 1 closest to 0 like 1 is, but then as we go farther left, the numbers that we're used to seeing without the negative sign seem to get bigger. For example, 5, which we're used to seeing as bigger than 1, is now to the left of 1. It's because negative 1 is actually greater than negative 5. But before we go on, I want you to take a second, pause the video if you like. I'm only going to give you about 5 seconds if you don't pause the video, so pause the video and think about it for 30 to 60. What do you notice about the positive and negative numbers with the same number value? Now, I've put number value in quotes because it's not really the name for what's going on here. And we'll get to that in a second. But what do you notice about, say, 1 and negative 1? What do you notice about, say, 4 and negative 4? And see if you can look through a whole bunch of patterns like that, 1s, 2s, 3s, 4s, 5s, etc., and see if you can come up with an observation about all of them. So go ahead and pause the video. You don't have to write it down, but make some observations and come back when you're done. So among the number of observations you could have made is that the 1s are closest to 0, whereas the 5s are farthest from 0 on this number line. We have 2s and 3s between 1 and 4, so the number pattern is familiar, 1, 2, 3, 4, 5, just in opposite directions on the number line. And what you may not have noticed, or maybe you have but didn't think to write it down, is that these 1s are the same distance from 0 on the number line. 1 is the next integer from 0, and negative 1 is also the next number from 0. The same thing is true if we looked at the 3s. The 3 is 3 jumps away from 0, or value of 3 away from 0, where the negative 3 is the same way. And this observation that the 1s and negative 1, 2 and negative 2, 3 and negative 3, etc., are the same distance away from 0 is at the heart of something that we call absolute value. So let me give you a second to look at that observation with a little bit more detail here. The positive side, I've moved the numbers so that we can really see what's going on. The 1s are the same distance from 0. The 2s are the same distance from 0. The 3 and negative 3, 4 and negative 4, 5 and negative 5, etc. All of those numbers are the same distance from 0, 5 and negative 5. And if we extended it out to 10 and negative 10, 12 and negative 12, 100 and negative 100, we would observe the same thing. So this is an observation that is critical to absolute value. The absolute value of a number is its distance from 0 on a number line. And before we get into exactly what that means, I want to give you an example of something that you're probably a little bit more familiar with than talking about absolute value, and we're going to talk about distance on a map. Now, the center of this map, we have the city in Ohio, Cincinnati. Now, Cincinnati, I chose Cincinnati because it has a fairly close distance to a whole bunch of different cities. So if we look, and of course this isn't going to be exact, but if we look at this map, it looks like Louisville to Cincinnati, Indianapolis to Cincinnati, and Columbus to Cincinnati are all about the same distance. Maybe Columbus is a little bit farther, so it's not a perfect look here. If we wanted to say some things are more or less the same distance away from each other, we could say Indianapolis and Louisville are about the same distance from Cincinnati. Now, it doesn't mean they're in the same direction. In fact, they're in different directions. Indianapolis is up to the northwest, Louisville is down to the southwest, and Columbus is up to the northeast. But the point is that they are all fairly similar distances away from Cincinnati. So now that we've looked at that, let's get rid of these observations and see if we can come up with a few new ones. Again, Cincinnati circled in red. Take a second, see if you can find a few other cities that seem to be about the same distance away from Cincinnati as each other. Now, if we're looking at a straight line distance as opposed to a distance on roads, that could be potentially different, but we'll look at it on roads. We can see that maybe St. Louis and Pittsburgh are about the same distance away from Cincinnati, except St. Louis in the western direction and Pittsburgh in the eastern direction. Maybe we can look now in yellow to observe that Cincinnati to Detroit is probably about the same distance as Cincinnati to Nashville. Again, in yellow, about the same distance. We're not being exact here because it's on a map, but the point remains the same. They are moving in different directions, but they are the same distance from Cincinnati. And finally, we can observe that perhaps Chicago and Knoxville are the same distance away from Cincinnati, or about the same. Again, Chicago then is moving up to the northwest of Cincinnati, and Knoxville is almost due south. So with that in mind, I want to go back to numbers with absolute value and talk about what it means for them to be the same distance from zero. Now we're going to go back to the number line where we saw the positives and negatives, the ones and negative ones, the twos and negative twos, threes and negative twos, so we can look at this idea. Now 1 and negative 1 are both the closest whole numbers to 0, although 1 is positive and 1 is negative. So they are the same distance away from 0, though they move in different directions. 3 and 0 are the same distance away from each other as negative 3 and 0. Because as we noticed on the map, we can say if, for example, Cincinnati and Chicago turned out to be 300 miles away from each other, which is not entirely true, but for the sake of this example, let's say they're 300 miles away from each other. If they are, if Knoxville is also 300 miles away, that distance remains the same, even though Chicago and Knoxville are off in different directions from Cincinnati. So that gets us to what we call absolute value, and where the absolute value of a number is its distance from 0 on a number line. So we represent absolute value with two vertical lines. Anytime you see two vertical lines, which it's important, don't be confused with absolute value in parentheses. These do not mean the same thing. Absolute value is two vertical lines, and it just asks you what the number's distance from 0 is on a number line. Now, if we look at the absolute value of 5, the difference between 5 and 0 should be pretty obviously, let's take a jump here, should be pretty intuitively a distance of 5. Now, if we look at negative 5 is also 5 whole number jumps away from 0 on a number line, but 5 is negative. That turns out to be significant in the placement of negative 5 on the number line. Some of the integer operations we'll get to later, but in terms of absolute value, negative 5 is the exact same distance away from 0 as 5 is on the number line. So a positive number or a negative number, no matter what type it is inside the absolute value, those numbers actually have the same distance from 0. So if we look at it down here in our example, it turns out that, for example, 3 and negative 3 have the same distance from 0. Now, if we wanted to, we could extend this pretty much to any other number that we wanted. If we wanted to talk about 7 and negative 7, we could. They are the same distance from 0. They are both 7 units away from 0. If we wanted to talk about 13 and negative 13, they are the same distance from 0 on a number line. So I'm going to take you through a few examples here to keep talking about it. For a decimal, the distance, again, is positive, so the distance from 0 is just 1 and 35/100ths. Because remember, a decimal is just a number, a location between 1 and 2. For 7/12ths, or rather negative 7/12ths, the distance from 0 on the number line just turns out to be this numerical value here, which is 7/12ths. Doesn't matter that it's on the negative side as far as absolute value is concerned. For negative 18, that distance is just a positive 18, because from 0 to negative 18 is still a distance of 18. And finally, I use this example of the opposite of the absolute value of 12 because I wanted to get you to notice that there is a negative sign here. It is not inside the absolute value, but rather it's talking about the negative of the absolute value. The absolute value of this is 12, but this negative sign can't be removed by the absolute value because it's outside. So what we're actually looking at is negative 12. So if the absolute value is on the if the negative is on the inside of the absolute value, it's more or less taken away because distance is always positive. Whereas if it's on the outside of the absolute value, you keep the negative sign because it refers to the negative of the absolute value. So go ahead, pause the video, and work on these 8 problems here. Shouldn't take you too long. I know it's more than normal, but shouldn't take you too long to look at. Remember to keep track of where the negative sign is, inside the absolute value, outside the absolute value. And remember that absolute value is just a distance. So go ahead and pause the video and come back when you're ready. So let's go through these pretty quick. 215 is just a distance of 215 on the number line from 0. 27 is a distance of 27 on the number line. But the negative sign is referring to the absolute value. It's not inside the absolute value, so the distance is 27, but we keep the negative sign because it is outside the absolute value. It becomes the negative of the absolute value. For number 3, 1/2 and negative 1/2 are both a distance of 1/2 away from the number line. For number 4, the negative is inside again, so the absolute value of negative 5 and 4/100 is just 5 and 4/100. That's the distance from 0 on a number line. The absolute value of negative 215 is still a distance of 215 away from 0 on the number line. So we can just write it like that. Notice that negative 215 and 215 do, in fact, have the same absolute value. 77 is just a distance of 77 away from 0 on the number line. Again, this is the opposite of the absolute value of 8. The absolute value of 8 is 8, but the negative sign is outside the absolute value sign, so it is the opposite of that, or negative 8, and 0 is itself, so the distance from 0 to itself on the number line is 0.